Good afternoon, everyone. Since it's 3 o'clock, I'll make a start. So welcome to session E on uncertainty and downside risks. So all presenters will have 20 minutes to present, and there'll be 10 minutes for Q&A. If you have a question, please submit it using the Q&A facility at the bottom of your screen. All questions will be covered in the Q&A session. And if you're invited to ask a question, we'll enable you to unmute your microphone. When you're asking your question, please introduce yourself by stating your name and affiliation. This session is being recorded. So let's begin with the first presentation by Simon Cheng from the American University. I'll pass over to Simon now.
Shredo, can you see it?
Yes, I can see it.
Okay, great. Thank you for conference organizers for having a paper in the program. This joint paper with Brent Mayer and Nick Parker, both from Atlanta Fed. So your disclaimer applies here. This chart shows the dynamics of inflation based on GDP price index. So all of you are familiar with this chart, but it's good to remind us of some basic facts. So inflation rate in the United States was high and volatile in 70s and early 80s, but it became low and relatively stable since mid-90s. So what you see here is 1 year ahead professional forecast from survey of professional forecasters in Philadelphia Fed. Those professionals made some episode, like if you look at here, Great Recession, recent pandemic, but on average, their forecasts tend to be unbiased. Now, if we add a year ahead household inflation expectations, the green line here, so what you would see, this household systematically and substantially overestimate the level of inflation. Okay, so tend to be, this upward biased as well documented in the literature. So finally, the red line here, we add a year ahead firm level inflation expectations taken from Livingston survey. Again, you see in terms of its features similar to the household inflation expectations, is kind of upward biased. So the question is, so why do firms and households hold aggregate inflation expectations that appear so disconnected from the actual inflation rate and the inflation expectations of those professionals? So in our mind, there are two answers. The short answer is that, as I show in the first page, the aggregate inflation in the United States had become so low and stable since mid-90s. Now, this made this concept, aggregate inflation, irrelevant in the minds of economic actors. So as a result, firms and households have become rationally ignorant. So the long answer here is, due to the lack of relevance that firms place on aggregate inflation, if we want to study the nominal expectations for the firms, it requires a different lens. In the case of a firm, that lens is unit cost, including both labor cost and non-labor cost. So unit cost for firms is equivalent to what we economists used to think about marginal cost. So when developing the survey, that was a language firm most widely used to identify the cost of producing the next unit of good or service. So here's some supporting evidence. At the firm level, many firms would report planning around the anticipated unit cost changes, and report unit cost changes influence their pricing decisions and their business decisions. At the macro level, if we simply aggregate the firm's perceptions and expectations, we would see a very tight connection to the aggregate inflation rate and to the inflation expectations of professionals and market participants. So let me give you some background of the survey. So we conduct a monthly online survey of about 500 CEOs, CFOs, and business owners in the 6th district of the United States, federal 6th district since October 2011. You can think about the southeast part of the United States covering at least 6 states there. Now, our survey is not very taxing. It takes less than 4 minutes to complete. We think this simplicity is a key to keep the relatively high response rate in our survey. Is about 40%. This is much higher than typical firm level survey, usually 20%. Okay, so we ask probability questions about firm unit cost expectations. So let me show you this questionnaire we sent out. So about the business inflation expectation survey, we call it BAE survey. The key question here: projecting ahead to the best reliability, please assign a probability to the following changes to unit cost over the next 12 months. If you look at the bottom of this page, you see there are 5 pre-specified intervals. So business owners are asked to assign probabilities to each of these 5 intervals. When you add them up, it should equal to 100%. So let me emphasize the 3 unique features of the BAE survey. So first, we focus on firms' own unit cost. As I'm going to show you later, this is a relevant concept to firms rather than aggregate inflation or price level in general. So second, we ask firms to assign probabilities to the bins about a year high unit cost. Now, this is in sharp contrast to typical firm level surveys that ask qualitative responses, say price level increase or decrease or stay the same. Okay, so finally, we track the same firms over time. Therefore, our survey includes this very rich panel structure that will allow us to see how firms update their expectations following the arrival of new information. Again, this in contrast to the repeated cross-sections in typical surveys of household and firms. Right. So there are 2 concerns here about our survey. The first concern is, as I briefly mentioned, so our survey covers the firms within the Fed 6th district, right? One may think, is the result we get here can be a good description of the firms at the national level? Right? To show you that some evidence, the answer is yes, right? Look, if you look at the firm size, the firms within 6 Fed district is very similar to the firm size across the United States. Okay. Second, if we look at industry composition, again, in terms of share of establishment and employment and share of payroll. So what do you see here? Across industries, the firm within 6th district, Fed district, is very similar to the industry composition across the United States. Right. So you may notice that our survey, BAE survey, oversampled the firms within manufacturing industry. So we do it on purpose because these firms within manufacturing sector is more sensitive to business cycle dynamics. So the last piece of evidence I want to show you is that if you compare, what you see here, we compare a year ahead inflation expectation from BAE, the blue line here, to a national firm level survey called Survey of Business Uncertainty, SBO survey. Right? You see those 2 surveys in terms of inflation expectations, they're highly correlated. Okay. Interestingly, in mid 2019, the SBO stopped asking this unit cost expectation question, partially because these 2 surveys kind of repeat each other in terms of this question. Okay. Just one of the reasons why SBO retired this unit cost expectation. Instead, they focus on investment and sales. Okay, so basically here, I show you the evidence that even if the BAE focus on the firms within in the southeast part of the United States, but however, the results are typical of the firms across the United States. Now, the second concern you may think is, look, we track the same firms over time, the last 10 years. The firm may, the forecast errors become smaller. They may be learning over time, but we don't see this kind of tenure effect or panel conditioning effect. What we plot here is the number of responses against the forecast error, right? You see it's very, a flat relationship, again, if we plot this against the absolute value forecast error or their forecast uncertainty, we don't see any systematic relationship. To summarize, we don't see any evidence of the tenure effect here. So having established the quality of the survey, so let me show you some experimental evidence why we ask firms for their unit cost instead of the aggregate inflation. In September 2014, we asked firms, so what do you think price level in general would change? Okay, so we asked question about the price level overall in the economy. So let me show you the result in next page. So what do you see here? When we ask firms for price level overall in economy, they give us the expectation a year ahead with a mean response 4.6%. Okay, and also there's substantial heterogeneity going on here. There's a lot of digital preference, 40% and 60%. Okay, so if we ask firms for price level overall in economy, instead the business managers, the decision makers, would give us an answer that are very similar to what household would tell us in terms of price level overall in the economy. Right? Now, to dig a little bit more into details, whether firms understand this concept doesn't matter to them. So in July 2015, we performed a randomized control trial. In the control group, the firms get the Michigan sequence price level in general. For the treatment group, they receive additional information that the price level in general is equivalent to inflation and measured by consumer price index. Now, the chart on the top shows the response from control group. We see here that a year ahead mean response is 3.7%. Now look at the chart on the bottom. This is the response of a year ahead inflation rate from the treatment group. They give us mean response 2.6%, which is about 1.1 percentage points lower than the control group, much closer to the actual inflation rate. Okay, and also if you compare these two distributions, you see not only their mean response is much closer to the truth, but also they give a distribution much less dispersed. Okay, so giving firms some clue that the price level in general means CPI inflation, it helps firms to understand this concept of inflation. Right. So in October 2020, we asked firms for their highest and lowest expectations for PCE inflation 2021. Okay, this is another RCT experiment we're doing here. So both group of firms get the median expectations for the PCE inflation, but for the treatment group, we also give them the 70% confidence interval. Okay, so the goal of this experiment is to test whether giving firms the information on the uncertainty about the policymakers' projections would affect firms' PCE inflation projections in October and their own unit cost expectation a year later. So the answer is no. Okay, so firms don't care about uncertainty in terms of policymakers' forecast. So to the best of our knowledge, this is the first experimental study that tried to estimate the causal impact of uncertainty on firms' expectations.
Simon, you have 5 minutes left.
According to my clock, I have 6 minutes, 15 seconds
Perfectly
left.
fine. That's perfectly fine. Okay,
thank you. Now here we ask firms for their the firms tell us that this directly, the monetary policymaker, the inflation expectations doesn't matter for their own unit cost forecast and price forecast. And also more than half of the firm tell us, look, this policymakers forecast has very limited influence on their own forecast. Okay, so to analyze this probability forecast, usually in the literature, it takes two approaches, so non-parametric and parametric approach. In terms of parametric approach, either normal and beta distribution works well. Both distributions assume the distribution is unimodal, but however, some firms give us bimodal distributions. Okay, so let me show you as a histogram here. Now consider this histogram in which firms assign equal probabilities to two beans. Okay, but these two beans are not adjacent to each other. So neither normal distribution or beta distribution would give us good fit. But however, if you look at the chart on your right, this is what we call bimodal asymmetric paranormal distribution. It gives us the best fit to this histogram. To tell you a little bit more about bimodality, it's quite common in nature, but we don't see many discussions in economics profession. So in our sample, about 338 histograms show bimodality. So we follow up with the firms to, with some interviews, having firms tell us more information about their expectations. So the majority of them give us some notion of conditional expectations. For example, if X happened, so my cost will be really high, but if Y happened, my cost will be really low. Okay, so respondents that have bimodal distributions are typically much more uncertain. Okay, so this scatter plot shows us the unit cost uncertainty against the absolute value of forecast error. So we see the positive and significant relationship. So more uncertain firms have larger absolute value of forecast errors. Those firm managers tend to know what they don't know. This scatter plot tells us, the association between unit cost expectation against their realizations. We see a very tight and positive relationship. Okay, so clearly firms' expectations are related to their outcomes. So for the sake of time, I'm skipping these 2 pages and have a brief summary here of what we get from the firm level analysis. So aggregate inflation expectations are not central to firms' pricing setting behavior. Instead, firms pay more attention to their own specific conditions. As some further evidence, we do a variance decomposition. So we decompose the variation in realized unit cost growth into its aggregate, sector, and firm-specific component. So what do we see here? The relative standard deviation of the sector-specific component is about 4 times as large as aggregate component. And the relative variation of the firm-specific component is about 7 times that of aggregate. Now, this evidence is consistent with the rational integration theory. Now, show you some aggregate evidence. On aggregate, firms' unit cost expectations move closely with a year ahead inflation forecast from professional forecasters. Okay. Now, this is one of our favorite graphs. That is, if we look at firms' unit cost perceptions over the last 12 months, it carries a very high correlation coefficient over 0.8 with inflation rate based on GDP price index. Okay. Now, this is quite amazing because remember, we never ask firms for their aggregate inflation expectations. So instead, we ask firms for their own unit cost growth, a concept that is familiar to firms and firms care about. But at the aggregate level, firms' unit cost expectations are so closely related to this inflation based on GDP price deflator. This last chart I want to show you. Let's zoom in the inflation expectations during the current pandemic period, appeared shaded in yellow. The upper left is a year ahead from inflation expectations. What you see here, in April 2020, a year ahead inflation expectation for firms dropped to 1.4%. This is the sharpest and largest decline we have documented since 2011 in our survey. Now, this decline in a year ahead inflation expectation at the beginning of the pandemic matched well with those professional forecasters, right? But however, if you look at the bottom chart, you see this inflation expectations a year ahead from New York Fed or University of Michigan. You see household increase their inflation expectations a lot at the beginning of the pandemic. To conclude, do firms understand the concept of inflation? It depends. If we ask firms for the aggregate inflation or price level in general, the answer is no. Firms will give you something that is similar to household expectations, right? But if you ask for firm unit cost, answer is yes. Firms care about, firms are familiar with this concept, right? So I would stop here and I hope Simon's still on time.
You're still on time, Simon.
Thank you.
Thank you. Very, very interesting talk, Simon. So if anyone has any questions, please write them in the Q&A. But let's start off with a question from Anna Galvo. Could please unmute Anna?
Okay, so my question is about how you ask in the survey about the probabilistic expectations about the unit cost. So you have a use of words and a use of events. Was that decided by the survey? You have any impact on that? Has any impact on any of the results you have? Hi, sorry, could you hear me?
Simon, you're still on mute.
Yeah, I'm muted, sorry. Yeah, and yeah, so it's a great question. Can you hear me well now?
Yes.
So are you asking that how do we set up these intervals?
Yes, yes. So, and why use words and limits as well? I mean, it's interesting. You're trying to make people understand what these events are. Does 5% a very large increase in unit cost? Does it vary across industries, I guess?
Yes, that's a great question, right? So we try to help the business managers to understand when we say, look, unit cost increase a lot, right? In terms of percentage, what does it mean? It turns out if we ask for unit cost, this kind of bound make really sense. On different experiment, we also leave this interval pretty open. We didn't assign any precise values, but this only applies to unit cost changes. It's okay. But if you want to ask for their investment and profit, so I would not take this approach. I would give them like open-ended question. Just say, ask them directly, what is your best scenario? What is the worst scenario forecast? Ask them to specify the interval.
Did you manage to measure the implied uncertainty and compare with some alternatives? Like you gave the intervals once on the inflation, right? Mm-hmm. Would the uncertainty coming from that question is similar to the ones one measure for inflation, or will be different?
Yes. In the chart, not here, but in the paper, we show that the inflation uncertainty come from aggregate at the aggregate level, come from our survey, is very highly correlated with inflation forecast uncertainty from the SPF, survey professional forecasters.
Okay, thank you.
Yeah, thank you, Anna. So the key point here is when you set up the question, you want to ask firms the concepts they're familiar with, right? Say unit cost instead of aggregate inflation expectations, which they don't care, especially in the United States, in such a low and stable inflation environment.
Do we have any other questions for Simon? I think we've got another one. So could we please unmute James Mitchell?
Hi, Simon. It's James
here.
Hey,
James. Yeah.
Hi. Great paper. Lots of interesting things going on. And so, I look forward to reading it properly. But I had a quick question specifically on one thing that I was particularly interested in, namely your your uncertainty treatments. I was particularly interested, I thought that was a particularly unique thing you were trying to do, to see how the uncertainty treatment causally affect the firm's expectations. And so I guess my question is, did you experiment with different ways of communicating that uncertainty information? I mention this because shamelessly plugging some own research of mine with Anna Galvao in a somewhat similar context, where we look at the responses of the general public to uncertainty information. Anna and I'll share the paper with you. Anna and I, in fact, find it's very important the manner in which one communicates this uncertainty information, namely whether as a confidence interval, do you use words, do you present it visually, do you present it more as a histogram, as a bell curve, as a fan chart, etc. In other words, the manner of communication we find has an important impact, certainly in our study, again, a randomized controlled trial, on how the households, how the public's expectations behave. So I wondered if you thought about this in the context of your survey and firms' expectations.
Yes, thank you, James. And I think I saw that Anna presented a paper in Bank of Canada 2 years ago.
Yeah, that's the right paper. Yeah, good job.
That's the right paper.
Yeah.
Okay, it's great, and we plan to do more RCT experiment. But definitely we're gonna ask, this time we're gonna ask the uncertainty in terms of like what you suggested, different ways to communicate uncertainty. But my sense is that if you ask something that firms don't care about, so I think the answer still be like similar. The answer is no. Firms, even if we change different ways to express uncertainty, firms don't care about aggregate inference expectations. But however, if we start asking something that firms care about, like maybe industry level uncertainty, it gives them like a producer price index at the industry level, using different uncertainty measures you guys have suggested, that would matter, I guess.
Yeah, I agree, and I think that'd be a great thing to explore. So yeah, good suggestion.
Yeah. Great. Let's keep in touch.
Thank you. Yeah,
thank
will
you.
do.
Thank
yeah,
you.
thank you.
And we've got time for one more quick question for Simon, if anyone has any further questions. If not, we'll thank Simon again. Thanks, Simon. So if Simon stops sharing his screen, and Andrea DePaulis, if you could share your screen. So Andrea's from Warwick University.
Yeah. All right. Can you see my slides?
I can see them, Andrea.
All right. Thank you. So, hi everyone. Thank you very much for having me here. So today I'll be talking about modeling and forecasting macroeconomic downside risk. And this is a joint work with Davide Delle Monache from the Bank of Italy and Ivan Pedrella from Warwick. So as again here, the usual disclaimer applies. Okay, so let me quickly just try to introduce why we think it's important what we do here. So we know that in general, like good policy making should rely on good forecasts. And by this, I mean not only like proper and accurate central scenario prediction, but also like a proper assessment of the risk around this central forecast. Specifically, many institutions, many policymakers recently tend to try and plan for the worst and not for the best. That is, try to like forecast, to predict what is the worst possible outcome, but still hope it will not necessarily realize. And clearly this type of approach heavily relies on measures of downside risk. Now, like the traditional forecasting framework in this environment has been mainly concerned with the modeling of mean and variance, so the first two moments of the predictive distribution of any variable, specifically GDP. But it's clear that when we need to take into account like downside risk, we need to introduce an additional concept, which is the one of asymmetry. And this has recently gained a little bit of momentum in some macro literature. Also, I think that there is a practical also importance to this, and that is because policymakers then eventually are often called to comment and to communicate what is in general referred to the balance of risk, that is basically for example, downside risk in excess of upside risk, or the other way around. And therefore, we think that actually having a proper tool, a proper device to model and predict the whole distribution of, in our case, GDP growth, it's quite an important task at hand. So what do we do in this paper? Actually, we do try to model the time variation in GDP growth distribution. And we know that in general, this time variation comes from two main sources. We have cyclical variations that often reflects the response of the economy to business cycle shocks, and for example, to what might happen in financial markets. And then we have secular movements, to be more specific, like permanent shifts in the long run distribution of GDP growth. Just to give you an idea, like the growth slowdown of the early 2000s, or the so-called great moderation or the deepening of skewness are among these secular movements that we try to capture in this paper. So what we do is we model the full conditional distribution of GDP growth. We will employ a flexible and asymmetric distribution, which belongs to the family of the T distributions. And we will directly model the time varying parameters for location, scale, and asymmetry. And as I just said, we will account for permanent and transitory component for all these three parameters. And we will also try to exploit some exogenous predictors to try and shape the moments of the distribution of GDP growth. So let me just give you a very quick overview of the results in case I run short of time. So what we find is that GDP growth features significant time varying asymmetry. And specifically, as is well documented, we confirm that actually recessions are characterized by, of course, higher variance, lower mean, and especially deepening negative asymmetry or skewness, if you prefer. Also, we document, interestingly, that there is a decreasing trend for skewness over the last 25 years. And this accounts for a large share of the long-run growth slowdown of the early 2000s. And also in the recent sample concerned with the pandemic, we actually find that the COVID shocks mainly pertain to the class of tail shocks rather than other. Also, we find that actually modeling asymmetry increases the out of sample forecast accuracy of benchmark of our model compared to other benchmark, and this happens especially at the short and medium horizon of 1 quarter and 1 year horizon. And eventually, we also find that actually financial indicators tend to increase estimation and prediction accuracy, especially because they feed into the time variation of the asymmetry component. Here, I just report like three main groups of literature we refer to. So clearly, we talk to the literature concerned in the skewness of business cycle fluctuations. We talk to the recent literature concerned with financial conditions as predictors of GDP growth, especially its downside risk. Notable and clear recent contribution is the one from Adrian and co-authors, which we're going to interface with later on. And here I have to say also that, of course, there are some papers that argue that this link actually is weaker than expected, even though we actually find out otherwise. And also, we relate to some macroeconomic theories, specifically the one concerned with the nonlinear propagation of shocks or the propagation of non-Gaussian shocks. Okay, so let me start with the modeling framework that we devise. So the GDP growth at time t, which is YT, in our framework is described by a location component, a location parameter, a scale parameter, sigma t, that multiplies an innovation epsilon t, which is distributed as a SKU t with new degrees of freedom. And rho t is a shape or asymmetry parameter that pins down, in fact, the asymmetry of the distribution. Let me just say, but I will repeat myself when it's needed, that this parameter is interpreted in a non-intuitive way, in a sense, as when it takes on positive values, it implies negative skewness, and when it takes on negative values, it implies positive skewness. All in all, these three parameters that we will let vary over time will map non-linearly to the first three moments, so mean, variance, and skewness. We can also write in closed form the log likelihood function of our SKU-T distribution, which is the one provided by Gomez et al. And we will use this and we will need this to actually we will exploit this in the time variation of this parameter. Why so? Well, because in this paper, we will find ourselves in the score-driven setting, okay? So first of all, we will consider a slight modification. We will consider transformation of the parameters. Specifically, we will consider the log scale and a transformation of the asymmetry parameter such that the rho t will lie on the unit circle, but we can model an unconditional parameter, which makes it easier. And then we will actually write down a law of motion for these parameters. And here again, we borrow from Krial, Lucas, and Koopman and Harvey, and we will exploit the score-driven framework, which posits this sort of common autoregressive law of motion. So the parameter at t+1 is given by an autoregressive component, and ST will be the driving force. What is this ST? Well, this is what we call the scaled score. And the scaled score is exactly given by the conditional score, so the first derivative of the likelihood function with respect to the parameter of interest, scaled by an appropriate function of past data, which in our case will be the square root inverse of the information matrix. And this basically allows ST to be a martingale difference sequence with the unit variance. Why do we choose the score-driven framework? Well, we know that thanks to Harvey and Koopman and co-authors, that this type of updating mechanisms are quite robust, and their theoretical properties are actually widely studied. And also, we find in a Monte Carlo exercise that this model properly tracks skewness, but only if it's present. So let me also give you a quick overview of what is the information processing put in place by the score. Well, the score is a tool that takes as an input the expectation error and translates it into a feasible updating for the parameter, which is actually what you can see here in this four plot. Let me mainly focus on this one first. These are omega t, which are a set of weights common to all the scores. And these weights put in place what we call the outlier downplay. So we know that in the Gaussian case, which is the black line, outliers are not taken into account at all. While in the case for a student t, we have this typical bell-shaped discounting. When asymmetry becomes either positive or negative, which in our case is going to be blue and green relatively, we can see that the discount will be harsher depending on where the asymmetry, on what side is the asymmetry, and on what side the realization of the scaled score, the scaled prediction error in this case, will actually belong. And let me also quickly comment here on this other panel. This concerns the updating of the asymmetry parameter, so the one that we are mainly interested in this case. And what you can see is that around turning point, so basically when we expect the asymmetry of the distribution to change, we can see actually that the updating will be quite sharp and the model will catch up quite quickly on what is happening with the underlying distribution. As I said before, we will model every parameter consisting of two components, a long run component, which it's denoted by a bar, and a short run component, which is denoted by the tilde. And then eventually we will also add some predictors. And in our case, this will be financial predictors, specifically the National Financial Condition Index from the Chicago Fed or its 4 subcomponents. How do we estimate all this model? Well, we devise a Bayesian estimation framework. Specifically, this allows us to impose like quite conservative priors on the time variation of the parameters and also on the predictor loadings. And also it allows us to account for parameter uncertainty when we will produce forecast. And we will retrieve like posterior distribution by an adaptive metropolis hastings algorithm. And of course, we use quarterly data, and our sample spans basically from the early 70s to the end of 2020. Okay, so let me show you some results. So here, I just report the first 2 moments of the predictive distributions that we estimate over time. So the expected value and the standard deviation, the volatility. In blue, you can see the full model, the full moment, while in red, you can see only the long run moment. And what you can see is that, of course, like we capture the cyclicality of the expected value, of the counter cyclicality of the volatility, but the long run component are possibly the most interesting. And as you can see here, we clearly capture the long run growth slowdown of the early 2000s, and also the grade moderation it's present in our estimation. And these 2 facts will be actually very interesting to comment also in light of the next results. So here I also show you the skewness. Okay, so we are able to filter out like a measure of skewness for the distribution of GDP growth, and we can see that this is in fact like procyclical, as it tends to fall down ahead and during recession. And specifically, the fact that it falls down ahead of recession is attributable to the presence of financial variables, given that the filter that we put in place is only a one-sided filter. And also you can see from the long run component that actually this long run skewness tends to fall basically starting during the grade moderation, and it keeps falling until the most recent period, and it tends to turn negative like right after the great financial crisis. And this suggests that in fact the economy tends to be characterized by an increasing downside risk. We also want to actually investigate how much like higher order moments impact on the expected growth. So our modeling framework allows us to put in place this decomposition where basically expected GDP growth will be given by the location component and then a function of higher order moments where we account for, of course, like the shape and the scale and the asymmetry parameters. So here I report this decomposition, and as you can see, like most of the cyclical variations, especially around recession, is driven mainly by movements in asymmetry. In the long run, we present the same decomposition in the long run, and again, what you can see is that the long run growth slowdown of the early 2000s, it tends to happen exactly when the long run skewness tends to start falling more and more consistently, and so basically we say that this increasing downside risk actually accounts for a large share of this slowdown. We can also say something about the volatility of GDP growth. Specifically, we decompose the total volatility into upside and downside volatility, and this is actually easily done in our framework because basically we can use like the asymmetry parameter as a weighting scheme. And what happens is that we see that the counter cyclicality of volatility that we saw in the full moment, it's actually mainly due to fluctuations in downside volatility rather than in good volatility. And this is to some extent also reflected in the long run again. And we can see that over the grade moderation, like the decrease in US volatility, it's mainly a decrease in what we call the upside volatility, the good volatility, rather while the downside volatility tends to remain quite constant even to these days. Okay,
Andrea, you
so
have
let me.
about 5 minutes.
Perfect. I'm just going to give you like a quick overview of the forecasting performance of our model. So we produce like 1 quarter and 1 year ahead forecasts. We use real-time GDP, and we will evaluate the forecast compared to some benchmarks, which I'll talk about. And we will try to evaluate point forecast and density forecast, specifically also focusing on the left tail forecast. So here you have a comparison table with a benchmark Gaussian AR2 model with stochastic volatility, and ratios smaller than 1 will indicate that the column specific model is actually better, except for log score, for which we expect positive results. So we take into account 3 different models: a SKUT without predictors and 2 SKUT with financial predictors. And we can see in the first place that allowing for asymmetry and for it to vary over time greatly improves forecast against like a very common benchmark. If we include financial predictors, this score increases even more. And especially during recession, financial predictors tends to be like quite game changers. We also compare our models against a state-of-the-art one, especially the one of Adrian and co-authors. And what you can see is that, especially in the last, like during the post 2000 the post 2000 sample, our model tends to be quite competitive and basically never significantly underperforming with respect to Adrian et al. And it also turns out that our forecasts are the only one against like the benchmark that I presented so far to provide like a perfectly calibrated forecast, not only for the full distribution of the forecast, but also only considering the left tail, the ones pertaining downside risk. We also evaluate some downside risk prediction and measures out of sample. And specifically, here we report very quickly like the expected short for an expected long rise and the probability of prediction in the next 4 quarters. And what we can see is that actually time varying asymmetry coupled with predictors tends to be like the best mix in our case. Very quickly, I want to talk about financial predictors. So we see in an in-sample decomposition that actually different financial predictors tends to feed heterogeneously into the time variation of the parameters, specifically of the asymmetry as it's reported here. So this is the unconstrained parameter delta tilde. And given this, we also want to explore what is the information content of many financial predictors when it comes to out-of-sample forecasting. So what we do, we condition the time varying parameters to the entire set of contributions to the NFCI. These account to 105 financial indicators. And we will put in place a shrink then sparsify approach. So we will try to just get rid of the uninteresting one and just set to 0 this uninteresting coefficient so as to like reduce the noise, the estimate. Well, what it turns out is that actually this big data model, as we call it, turns out to be quite useful, especially for recession in the short term. And also here you can see an extremely good performance. These are compared to our preferred model, the SKUT with the 4 financial predictors. And here you can see an extremely good performance for the full sample. But what you can see is that actually these are mainly driven by the pandemic period. So this big data model tends to perform very, very well, especially in the last year, but not much so over the full sample, as of course probably we will just pay the price of overfitting. And this is just the last chart I want to show you, where basically I show you the percentage of the 105 predictors that are selected and predict the 3 parameters that we model. And what you can see is that most of the financial predictors actually tends to feed into the asymmetry parameter rather than the location and scale. Okay, so just I want to conclude very quickly. So we find that the distribution of GDP growth does exhibit significant time variation in the first 3 moments, and we introduce a flexible parametric approach to characterize this full condition distribution. We find that the real economic growth then feature procyclical skewness. This and it has a decreasing long run trend that's decreased over the great moderation period and tends to account for a large share of the growth slowdown and actually of the reduction in volatility. Also, financial variable tends to anticipate an increasing downside risk to the economy and improves density forecasts, especially around recession. And eventually, we find in some results that I didn't report in the slides that actually credit and leverage indicators tends to drive the asymmetry dynamic. And this relates to many of the story that try to comment on the causes of the Great Recession. And one, for example, would be like the building up of household leverage proposed by Mian and Sufi and Horda and co-authors. So I guess I'm still on time, and thank you very much. Looking forward to some questions.
Thank you, Andrea. Do we have any questions for Andrea? Haven't seen anything in the Q&A yet. Any questions? Okay, we have one from Gary Coop. Could we unmute Gary, please?
Hi, this is just a little question.
Hi, Gary.
Through. Nice talk, by the way. You had a figure about halfway through of that vol plus and vol minus on it.
Yeah.
Could you just take us through what was happening in the pandemic? Because vol plus goes way up. That's the one place where vol plus goes up, isn't it? Well, anyway, what's happening there?
Yeah, well, I guess that, so we didn't really think much about it, I have to be honest. I think that in true honesty, this is a little bit of a mechanic response of the model. So you can see also here that the volatility tends to spike and asymmetry tends to go abruptly down and up. Not much, but still a little bit. And I think then that basically what you see is that the bad volatility tends to spike a little bit beforehand, the blue one. And this is in conjunction with the fall in skewness to the, again, when the extremely negative realization was, when we saw the extremely negative realization. And then actually you see that while this red line goes down, the blue one goes up. Probably then this is because a skewness rebounds a little bit, and this feeds into the positive, into the upside volatility. And of course, you can see the immediate reduction of the downside volatility. But I mean, I don't know if I can say much more about it, because I guess it's just 2 small points, and it's mainly related to what happens to the skewness in the estimation. I don't know if that answers your question.
Okay, kind of. Because the actual data, of course, GDP really fell and then really grew.
Yeah, exactly.
And then I guess it's sort of, but it's sure fitting it very quickly, isn't it? These changes. And
the fit is quite very quick, very sharp. I mean, also I would say that probably with more data, I mean, these 2 points would also be diluted a little bit, or after, while now probably the estimation really stops there and they remain at this high level. But this is probably just a guess.
Thank you.
Thank you, Gary.
And we have another question from Martin Wheel. Could we please unmute Martin?
Yes, I suppose, I mean, my question is that your measures of skew seem to be rather well determined, whereas intuitively you might think that the events that give rise to clear skew are perhaps relatively rare. So can you give any intuition onto what is it in the structure of the model that leads to this being quite well determined?
Okay, so I mean, if I understood correctly the question, I think that so first of all, I guess that the updating mechanism that we put in place, so that score-driven updating that I showed you here, I mean, this really helps a lot in picking up what is happening in the data. Okay, so, and especially like with the skewness, as you're mentioning, when you say that it's well defined, I think that you mean that it actually fluctuates like as one would expect. And this is again probably a feature of the fact that the updating, it's quite sharp, especially around turning points, so where you would see like the skewness start going down or reverting back up. And I think that this is like quite a plus of our model, quite a strength of our model. And also, as I mentioned, maybe too quickly in the presentation, I mean, I guess that the financial predictors really tends to really help a lot in describing what is happening and the skewness. And this is probably like, this is contained in this question, and you can in this plot, sorry, and you can see that like the contribution of financial variable tends to be more and more, of course, during period ahead and during period of recession, and this clearly like allows the model to estimate the parameter more clearly, more neatly, if anything. So I guess that probably these are the two main points that allows us to get this nice shape for skewness.
Thank you very much.
Thank you.
We have time for one more question. If not, then we'll thank Andrea again. Thanks, Andrea.
Thank you. Thank you, everyone. Thank you, Charlotte.
Okay, I guess I gotta take over. Our last speaker here is Charlotte Davidson. She's gonna talk about measuring international uncertainty spillovers and their impact on the economy. So you have about 20 minutes. Okay.
Okay, Simon.
Okay, the floor is yours.
Thank you. So this paper, as Simon said, is on measuring international spillovers in uncertainty using a large forecast data set. And this is co-authored work with Joshua Beckman, Rainer Scheussler, and Gary Koop. And I'd like to thank the conference organizers as well for including our paper in the program. So I'll begin with a brief overview of the literature and motivate our study somewhat. And then I'll discuss the data set used, which is a key part of our paper, and the econometric strategy. And I'll give an overview of some of our key results. So I think it's now well understood that uncertainty has a negative effect on the economy. So starting with this seminal paper by Bloom, there's been many, many papers documenting the effect of uncertainty on the economy. But there are many components of uncertainty. So we've had papers considering macroeconomic uncertainty, financial uncertainty, monetary policy uncertainty, economic policy uncertainty. So the list goes on and on. So we're now starting to think in a more granular way about uncertainty. And although there's deepening integration between countries, it's unclear to what extent uncertainty in a specific economy affects other economies. So if we look at the literature on uncertainty spillovers, the existing literature primarily addresses spillovers and uncertainty using the concept of global uncertainty. There are some exceptions, which I've listed at the bottom. So there are some papers which may use a small-scale VAR approach, for example, to consider economic policy uncertainty spillovers, where you can see, say, a spillover from Germany to France. But in general, the big body of research focuses on global uncertainty. This first group of papers here econometrically estimate global uncertainty. So they may use large-scale VARs, so Berger, Carrero et al., Quaresma et al., use large-scale VARs to econometrically estimate uncertainty. So you use a large cross-section of variables and use their volatility to generate an estimate of global uncertainty. Mumtaz and co-authors use a fairly similar approach, but instead use factor models, and they decompose the variation in variables into variation explained by global uncertainty, regional uncertainty, and country-specific uncertainty. Osterk and Sheng take a slightly different approach. They use forecast data to construct proxies of uncertainty. So they consider country-specific uncertainty and then use this to create a global uncertainty measure. And a key finding across many of these studies in general is that global uncertainty often plays a more important role than domestic uncertainty. But the question then is which countries and which components of foreign uncertainty dominate? Before going on, it's also worth mentioning that there are many different ways to measure uncertainty. So I've already mentioned that we can econometrically estimate uncertainty. So starting with Gerardo et al.'s paper, who considered macroeconomic and financial uncertainty, there's been subsequent papers which have econometrically estimated uncertainty. We can also use textual analysis to derive uncertainty measures. So that's quite common when we want to look at economic policy uncertainty. And a final strand of literature looks at the dispersion of survey-based forecasts. Okay, and in general, when we look at uncertainty from that perspective, we can obtain uncertainty measures corresponding to observable variables. So uncertainty around industrial production or interest rates or exchange rates. So the objective of this paper is to begin to look at things in this more granular way. Rather than considering a global uncertainty shock, can we consider different countries and can we consider different components of uncertainty? So we look at spillovers and uncertainty across the G7, India and China. So we include our key advanced economies as well as some of the key emerging economies. We'll be looking at spillovers in 5 components of uncertainty. So we'll consider uncertainty surrounding industrial production growth, interest rates, inflation, exchange rate, and the current account. Okay, so for each country, we're going to have 5 different components of uncertainty. And we use different survey-based empirical proxies for uncertainty constructed using a large professional forecast data set. So the forecasters will be considering the future, and they'll make a forecast, say, of what they believe the interest rate will be next year, and we can use that to construct a measure of interest rate uncertainty. So we want to consider things in a more granular way, so we want to use a VAR. So we estimate a large multi-country Bayesian panel VAR with around 50 variables, and we explicitly account for interdependencies between different economies. But of course, in doing so, we're estimating a very large model, and we need to also overcome overparameterization concerns. So this will be our overcoming these overparameterization concerns will be addressed in our empirical strategy. But firstly, let me give a bit more information about the survey data. So we use survey data from Consensus Economics. Consensus Economics has a number of different institutions which provide forecasts. So for example, HSBC or Morgan Stanley. And these institutions give Consensus Economics point forecasts of macroeconomic variables. Most of these institutions' names are published, increasing the incentive to provide actual expectations. Okay, so there are reputation effects. We use forecasts for the subsequent year just for consistency across our different variables to construct our uncertainty measures. And Lahiri and Sheng show that forecasts can be used to obtain 3 empirical proxies of uncertainty. And this decomposition has also been used in other studies. Estrefi and Muabi consider interest rate uncertainty, and Ozturk and Sheng, which I previously mentioned, which construct country-specific measures of macroeconomic uncertainty. So what is this decomposition? Okay, so we've got our forecast data, and we're going to construct 3 proxies of uncertainty. So the first proxy has been widely documented. So it's forecast a disagreement. This captures idiosyncratic uncertainty. So the intuition behind this is, to what extent do our institutions disagree in their expectations about their future? If they disagree a lot, there's more uncertainty. If they disagree less, there's less uncertainty. But looking at disagreement alone isn't enough. We need to consider another aspect of uncertainty. So we'll also look at common uncertainty. So this is based on the variance of forecast errors, and what your forecast error captures is the extent to which institutions' expectations about the future differ from what we actually observe. So a forecaster makes a forecast about the interest rate next year. What was the actual interest rate? What's the difference? That's our forecast error. And we can then sum these two measures together, idiosyncratic uncertainty and common uncertainty, to obtain an aggregate uncertainty measure. So our sample is from the mid-90s to 2016, and this is just, the end date is based on when our survey data ends. We have 7 units in the analysis, so we include the euro area as one unit on its own. For each country, as well as having 5 different components of uncertainty, we have 2 macro financial variables. So we have industrial production growth and we have stock price growth, so that we can examine the effects of uncertainty on the real sector and the financial sector. And we have, as I mentioned, 5 components of uncertainty. And broadly speaking, these aspects of uncertainty relate to business cycle uncertainty. So uncertainty around output growth closely relates to the notion of business cycle uncertainty. We also have monetary policy uncertainty, in that we have interest rate and inflation uncertainty, and international dimensions of uncertainty. So we think of the exchange rate and the current account tending to fall into this 3rd category. So all in all, we have 7 units with 5 components of uncertainty and 2 macro financial variables each. So we have 49 variables in our VARs, and we also include some controls for the Asian financial crisis, the global financial crisis, and we control for some other global dimensions of uncertainty. So we've got some exogenous variables in our model as well. So we don't have data on common current account uncertainty. So one of our models will only have 42 variables. So we estimate 3 multi-country panel VARs, 1 for each uncertainty proxy. So we estimate a panel VAR with idiosyncratic uncertainty, 1 with common uncertainty, and 1 with aggregate uncertainty. And this is so we can compare how the spillovers vary depending on which proxy we use. So if we exclude exogenous variables, the VAR for the country I can be written like this. So country I, so let's say this is China. China, what happens to Chinese industrial production growth depends on China's variables and uncertainty variables, but it also depends on all other variables in the model. Okay, so each country's variables is allowed to affect every other country's variables. In order to start thinking about how to overcome the issues associated with overparameterization, we define interdependencies in the same fashion as Canova and Ciccarelli. So dynamic interdependencies occur if lags of country I variables enter into country J's equations. So these are through our coefficients. And static interdependencies represent contemporaneous relationships between economies. Okay, so this is going to be through correlations in the variance covariance matrix. So if we have an unrestricted panel VAR, it assumes that dynamic interdependencies and static interdependencies between every country pair exist. Okay, so we assume, if we estimate this in an unrestricted fashion, we assume that every country can affect every other country in every possible way. Now, to improve estimation, to make it feasible, we extend an existing algorithm by Coop and Karobolis, who consider restricted panel VARs. So what they do is they restrict dynamic interdependencies and static interdependencies by setting matrices of parameters to 0. Okay, so for example, does China affect India with a lag? Yes or no? If it's no, then we set that matrix of parameters to 0. So, but what we do in our algorithm instead is we consider blocks of parameters. Okay, so we consider whether one group of variables, either uncertainty or macro or financial variables, can affect uncertainty or macro financial variables in another country, either dynamically or statically. So we can use the unrestricted panel var with this extended prior to impose any of these restrictions. And we do a single run of the algorithm, which draws on restricted models. And the results produced are an average across many restricted models. But the most important takeaway part is that the probability that parameters are not zero and that a dynamic or static interdependency should be included is captured by a posterior inclusion probability. Okay, so we can report the probability that each interdependency should be included in the model. So should the uncertainty variables in the Eurozone affect the macro financial variables of the UK? That would be one interdependency you could report. Does it exist or does it not exist? Or to give another example, does Japanese macro financial variables, do they contemporaneously affect, say, Indian macro financial variables? With 49 endogenous variables, of which 35 are uncertainty variables, we need to summarize up to 2,000 relationships. So we need to think of a way to summarize these effectively. So what we do is we have 3 layers of results. In the first layer, we provide an overview of uncertainty spillovers at the economy level, using our posterior inclusion probabilities to examine dynamic interdependencies and static interdependencies. So I'll show that in figures 1 and 2. So remember that dynamic interdependencies are asymmetric. So for example, Eurozone uncertainty may affect British uncertainty with a lag. So there's a direction there. But in terms of static interdependencies, they're symmetric. So Eurozone uncertainty may immediately affect British uncertainty, and that implies that British uncertainty immediately affects Eurozone uncertainty. So this is all working within the reduced form of the VAR. We'll then consider an overview of spillovers at the component level. So now, rather than just focusing on uncertainty, we want to look at, say, interest rate or exchange rate or current account uncertainty. We'll look at these spillovers using generalized impulse response functions. And we'll use the method of Pesseran and Shin. Finally, we'll look at the Diebold-Yilmaz connectedness index resulting from generalized forecast error variance decompositions. And we'll use this to compare across our different uncertainties proxies. And in general, we've opted for methods which are invariant to the ordering of the variables, which is an attractive feature given the huge number of variables in our VAR. Simon, can I check how I'm doing for time?
You have about 5 minutes left.
Okay, great, thanks. Okay, so let me go through my results. So in general, I said to you that I've got idiosyncratic uncertainty, common uncertainty, and aggregate uncertainty. So I'm going to focus in on aggregate uncertainty for most of the results for clarity. But if you wish to look at the different, how the results differ across uncertainty proxies, then you can look in the main body of the paper. But in general, idiosyncratic uncertainty and aggregate uncertainty tend to produce similar results, whereas common uncertainty tends to produce quite different results. So first of all, let's look at dynamic spillovers and aggregate uncertainty. So these are our dynamic interdependencies. So this is looking at whether, for example, if we look at USA, does lagged US uncertainty enter British macro financial equations? Okay, so does US uncertainty affect UK stock prices and industrial production with a delay? And if the answer is yes, then we include a link on the diagram. So we can see, looking at these dynamic interdependencies, we can see many examples of spillovers and uncertainty. In general, almost exclusively, we see spillovers from the uncertainty blocks to the uncertainty blocks and macro financial blocks. We can only see one example of where macro financial variables affect another block with a delay. We can see the US is an important source of uncertainty, but it's not the only source, and it's not particularly dominant either. We can see the Eurozone also features quite importantly. And I summarize these results on the next slide. So as I said, there's considerable evidence of international uncertainty spillovers. DIs almost exclusively originate from the uncertainty bloc. The US plays a strong role internationally. Another important finding is that spillovers from domestic uncertainty to domestic macro-financial blocks are less common, and this is in keeping with the finding in the literature that international uncertainty is more important than country-specific uncertainty. And in general, what we're starting to see is that there's not one simple source of global uncertainty, and using our VAR-based approach, we can start disentangling these individual sources of uncertainty. So these are the spillovers summarized from our coefficient matrix. What information are we getting from our covariance matrix, which looks at contemporaneous linkages? So these are static interdependencies. So these are interdependencies in our covariance matrix. And remember, these don't go one way, they're symmetric. So if US uncertainty affects British uncertainty, this implies that British uncertainty also affects US uncertainty. Okay, so there's not a direction in these diagrams. So in general, we can see that these are more sparse, and we can see more connections between our macro financial blocks. So they are similar stories, but much more sparse. Spillovers between macro financial variables are sufficiently captured by static interdependencies, but the effects of uncertainty materialize with a delay. Okay, what do I mean by this? Well, we can see links between our macro financial variables in this diagram more often, whereas we can see that in the first diagram, we could see all the spillovers originating from our uncertainty blocks. So uncertainty materializes with a delay, because remember, these are our lag terms in our coefficient matrix, and these are from the covariance matrix. Another interesting finding is that in figures 1 and 2, we can see that uncertainty shocks in each of our emerging economies affect uncertainty or macro financial variables in the other emerging economy. So we can see some relationship between China and India as well. Now let's look at our generalized impulse response functions. Okay, so this figure summarizes impulse response functions. And what we do is we plot any impulse response functions where a shock to uncertainty, so let's say industrial production uncertainty in the US, it has a negative effect on Chinese stock prices. Okay, so if there's a negative effect and it's not zero according to the credible interval, then we plot it on the diagram. So again, we can see the US is very important. Interest rate, exchange rate, and current account uncertainty seem particularly important, and these seem natural channels given the role of the US in the world economy. We can see that the financial sector tends to be affected more strongly, particularly in our emerging countries. And some other findings are that while the US is important, we can still see important spillovers coming through from our other economies as well. So let me summarize these findings. After this, I've got one more chart. So we see more evidence of spillovers from domestic uncertainty, but foreign uncertainty shocks play a similar or larger role. So this is echoing the finding from figure 1. So domestic uncertainty seems a bit more important here, but still foreign uncertainty shocks are still important or even more important. The financial sector being hit harder is consistent with other findings in the literature, this notion of a global financial cycle being driven by uncertainty, and Mumtaz's finding that financial activity tends to be explained more by global uncertainty, whereas real activity is explained more by idiosyncratic uncertainty. I've discussed the US spillovers. There's sizable spillovers from other economies, and again, we see an India-China relationship. these now summarize some information from the generalized forecast error variance decompositions. So if you're familiar with the Diebold-Yilmaz connectedness indices, so we can see that spillovers received by each macro financial variable from all uncertainty variables. So we can see that the effects of disagreement and therefore combined uncertainty or aggregate uncertainty are more important. And we can see that common uncertainty is less important here. So among our three uncertainty proxies, idiosyncratic and aggregate uncertainty explain more variation in the real and financial sectors compared to common uncertainty. And I think I'm running to time, so I'll quickly summarize. So overall in our paper, we find considerable evidence of international uncertainty spillovers. While the US plays a strong role, particularly through some certain channels, it's not dominant. We see substantive spillovers from other economies. Consistent with other studies, we find that the financial sector is hit harder by foreign uncertainty than the real sector. We find that idiosyncratic uncertainty spillovers are more frequently observed than spillovers in common uncertainty. But consistent with other studies, and I haven't produced charts to show this, but they are in the paper, when they do occur, foreign common uncertainty shocks produce larger negative responses. Hopefully the main aim of this paper is that it's hopefully convinced you that there's perhaps not one simple source of global uncertainty, and instead we need to disentangle these individual sources of uncertainty. And our VAR-based approach provides the means to do this.
Great, thank you. So is there any questions? So while others type in their questions, I'll start with my question here. It's great work, try to look at spillover effect of uncertainty shocks across countries. I've been thinking of doing this for a long time, but always had great trouble trying to distinguish the first moment from second moment. Taking US and China as one example, right? So US macro variables, US uncertainty, China macro variables, China uncertainty. So I can imagine immediately they're like macro variables goes to uncertainty and vice versa. Do you guys have any thought about how do you control the first moment shocks when you try to study the spillover second moment?
I think when we started looking at impulse response functions and things like that, I think we also, to be honest, it is really difficult to summarize these relationships between so many countries. I mean, there is the advantage that with survey data, you do have some timing assumptions which you can implement. So obviously, we know, I mean, the findings that we find, for example, here, they are come directly from the data set, because most of the forecasters, they will make their forecast before any change in the economy is observed. So there's the timing assumption there. So that implies that you could use some kind of short run restrictions, but aside from that, it is quite difficult with so many variables in the model.
Okay, great. I see some questions on a Q&A. I will start with Florian Huber. Can you unmute yourself, please?
Thanks a lot for this very interesting presentation. I actually have two questions. The first one is, in my own work on this topic, I always found that when I use observed proxies for uncertainty and consider impulse responses, these often generate these real activity overshoot in medium run responses. Do you also find these when you use your model? And the second question is, thinking of what you are measuring in terms of the network, you're assuming that the VER coefficients are constant over time. So the question is, when you would estimate this model over certain subsamples, whether you find differences in these spillover indices, because some of the economies you have in the sample gained importance in terms of trade shares and so on over the most recent sample. That's it. Thanks.
Thanks, Florian. Yeah, I think those are both really good questions. I think for the first one, I would need to, it's been quite some time since I've looked at the raw impulse response function. So I think that's something that's worth checking. In terms of your second question, I think looking at subsamples is definitely something we haven't tried yet, but we have thought about. In particular, I think it would be beneficial to estimate from the early 2000s onwards to start looking at the role of China and India, I think, which is what you were getting at.
Precisely, thanks.
Thanks.
Okay, I see another question by Karam. Ask, Karam, do you want to unmute yourself?
Hi, I have one question and then one comment maybe. So when it's about the static interdependency, I understand it's a covariance metric, so necessarily symmetric. But if you actually look at the structural form, a PP prime might be equal to sigma, so therefore you might easily have asymmetric effects. So do they really mean much in this reduced form version?
Yes, I think that in the reduced form, it's taking a first look at spillovers. So to make clear, we're not saying that the dynamic interdependencies, so figure 1 and figure 2, we're not saying that these are structural. So these are finding the initial patterns in the data within the reduced form. And they become naturally from the model because we need these features in the model to overcome overparameterization anyway. But these responses, which arise from the generalized impulse response functions, can be obviously asymmetric, and we wouldn't confuse them with these first set. Yeah,
I can easily write a structural model where like US is affecting everyone and no one is affecting US back. That's what you see also in the generalized, and your model is gonna then erroneously capture in the static spillovers that they are asymmetric effects, but there may be in reality none, right?
I think, yes, I understand what you're saying. I think the one thing that we found in doing the paper is that sometimes this assumption that the US is most exogenous, it's actually quite difficult because you're still seeing spillovers from other countries to the US. But I agree with you that it's hard to actually have an idea of the origin of spillovers when you're looking at static interdependencies. It's more saying, is there a contemporaneous relationship or not? But you're not getting a sense of direction when you're looking at the static interdependencies.
Thanks. And just a comment is when you're presenting these graphs and lines, that some of them look easy to understand, but some of them are really complex. Maybe you can standardize all of the variables and then give a median coefficient that might be easier to see in the table as well. Just, you know.
Yeah,
thank you,
I know
Karen.
what you're saying.
Thank you.
So I will take one more last question from Anna Gallo. Anna?
I'm just wondering if you're able to do historical variance decompositions, because something would be interesting. You have this notion that common idiosyncratic and aggregate shocks have different effects. And I'm just wondering if their relative importance change over time.
So that's not something we've looked at, but actually that does sound really interesting. Thanks, Anna.
Okay, and I have one more comment to say. Please go to in the coffee break. We have this Zoom link that you can get in during the coffee break, and we can just have informal chats there, so we can keep the conversation there. I'll be there. Okay,
thanks, Anna.
Great. Thank you, everybody. That's it. We are done with session on uncertainty downside risk. Thanks for everyone. I see you in the coffee room.
Thank you.